Hello guys, in this video we are going to be talking about some limit theorems and how we apply it to different examples in calculus. So if you are given a limit f of x as x approaches a to be L and another limit or a function rather given the limit g of x as x approaches a to be equal to m. There are some theorems that we are going to look into and examples on how to apply those theorems. Now, the first is if you are given this limit f of x plus g of x as x approaches a, it's the same thing as saying limit of f of x as x approaches a plus the limit of g of x as x approaches a. Then recall that I said that the limit of f of x as x approaches a is L. So since we know it is L and this is M, we just add both together and our answer comes out. So this is the example to show for this theorem. We are given the limit 3x squared. So this is the limit f of x. We can call this limit f of x and this g of x, and this is a constant. So this is the function f of x, and this is another function g of x plus a constant. So it is the same thing as saying taking this limit and adding it to this other limit as x approaches 1. So what we just do is to replace our x values with 1. This is what I've done here. And 1 square, we know it is 1, multiplied by 3 gives us 3 here. Same thing we do to the limit of g of x as x approaches a, where 1 is the a in this example. So we replace our x with 1 and we solve to get 10. Now that's as simple as it is. What if it is a negative? It's still the same step. You take the limit. It's the same thing as taking the limit f of x as x approaches a minus the limit g of x as x approaches a, where this limit up here is L. So it will be given as L minus m. And this is an example. So you see I've switched the signs here to a negative sign just to fit into this particular limit theorem. And so I have my 1 square, which is still 1 multiplied by 3 here, and my 1 multiplied by 4 here. My sign is still here, then my constant plus 3. Now this constant can be either negative or positive. It doesn't matter. So 3 minus 4 plus 3 comes out to be 2. Now, what if you are given the limit f of x multiplied by g of x? These two functions multiply together. So it's the same thing as saying the limit f of x as x approaches a multiplied by the limit g of x as x approaches a, where our answer comes out as L multiplied by m. And here you can see I've given us an example. This is 3 times 3x, which we say it is the limit of this function f of x, and this is 4x, which is this function g of x. So multiplying these two together, I'll have 12x squared. Now I take the limit. Even if I take the limit individually, I still come to a point of getting my answer as 48. So either way, you are still correct. The x here is replaced by 2 because x approaches 2, and we get our answer to be 4. 4 multiplied by 12, which is 48. Now, some other questions might come in this form. Let's say you are given the limit of this function g of m, which we already know that, or g of x rather, which we know that it is m, and m is not equal to 0. So you are given this limit here. Take the limit 1 over g of x as x approaches a. The answer comes out to be 1 over m, as long as m is not equal to 0. Now, this is an example to show for it. We have the limit of 1 over x squared as x approaches 2. Now we say 2 raised to power 2, that is 2 squared, will give us 4. Our answer is 1 over 4. Now, we are given another theorem here. If the limit f of x is equal to L and the limit g of x is equal to m, and m is not also 0, then a question can come in this form. Take the limit f of x over g of x, two different functions, as x approaches a. Now, it is the same thing as taking the limit of the first function and dividing it by the limit of the second function, and our answer comes out as L over m, provided that m, which is the divisor here, is not 0. But what if m is 0? We say that the limit does not exist. Now, I have an example to illustrate this particular theorem here, which is evaluate the limit x minus 2 divided by x squared minus 6 as x approaches 4. Now we replace our x with 4, which you can see here, 4 minus 2 divided by 4 squared minus 10, and we get our answer to be 1 over 5, which is 4 minus 2, 10, 16 minus 6, sorry, 4 minus 2, 2, while 16 here, which is 4 square, minus 6 to be 10, and our answer is 1 over 5. But in this other case here, we have the limit as x approaches 4 of x over x minus 4 to come as 4 divided by 0. And we say that this limit does not exist. So even if you type this in your calculator either gives you error or say not a number. So that shows that the limit does not exist. Now let's take further examples to see what we have learned so far. Now we are given these 4 examples and we are going to take them one after the other. So solution. We are given the first one as the limit of x squared minus 4x plus 4 divided by x minus 2 as x approaches 2. Now, like I have said, we replace our x values with the 2 and we see what comes out. So the limit as x approaches 2 of x squared minus 4x plus 4 divided by x minus 2 is equal to 2 squared minus 4 multiplied by 2 plus 4 over 2 minus 2. This comes out to be 4 square minus 8. Sorry, this is 4, not 4 square, minus 8, then plus 4 over 2 minus 2. And we can see that this comes out as 0 over 0. Now, this is quite different from the theorems that we have just looked at. Now, in a situation like this, we say that the answer is, or the limit is undefined. Now, there's a way we resolve this. There's a way we can resolve this. If the limit is undefined, we can check either the numerator or the denominator and further apply our knowledge of mathematics. Now you can see from here in the numerator here that this is a quadratic expression, and now this is a quadratic expression which can factorize into x minus 2 and x minus 2. Now, if you open this bracket, you discover we get this. So this is actually equal to this. Now, we can replace this expression, this quadratic expression, with this factorized form, and we get x minus 2 here. So we can see that we can cancel any 2, and we get our answer to be x minus 2, which x, we know it is 2 here, to be 2 minus 2, and our answer comes out as 0. So anytime we have a limit which is undefined, all we have to do is to take a look at the question here or the example and see if there is any way we can apply our knowledge of mathematics to further solve it. Okay, let's take the second example and see what I'm still talking about. The limit of x minus 2 divided by x minus 2 as x approaches 2. Now, we know that it is 2 minus 2 divided by 2 minus 2, which is 0 over 0, and it is undefined. Now, the same way we apply our knowledge of mathematics and see that from the question here, x minus 2 divided by x minus 2, we can see that this is equal to 1. It's like you saying 2 divided by 2, which is 1, or 3 divided by 3, 1, or 4 divided by 4, 1. So this divided by this is equal to 1. Then we can write the limit as x approaches 2 of 1, which is equal to 1. So this is our answer. The limit of a constant is that same constant. It doesn't change. So the limit of of 1 as x approaches 2 is still 1. So this can just be divided and this gives me 1, and that is my answer. Now let's take the third example. What I've given us here is 4 different ways these kind of questions can come, which is totally different from the theorems I've shown us. So the third example says the limit of x minus 3 divided by x squared minus 9 as x approaches 3. Now, we know we do our 3, which is the x here, minus 3, and 3 squared minus 9. And this tends to 0 divided by 0, which is still undefined. Now, again, we apply our knowledge of mathematics, and we can see that from basic factorization, that this is also a quadratic expression. This is also a quadratic expression. Like I've said, it's either you look at the numerator or the denominator, and you see that something can be done to either of them. So we can rewrite this, okay? This limit as x approaches 3 and of x minus 3 over x plus 3, x minus 3. Now you can see from this, we can get this. When you open the brackets, you have your answer as this. And since the both of them are the same, we can see that x minus 3 is here, x minus 3 is here, which can cancel out, leaving us with the limit of 1 over x plus 3 as x approaches 3. So this is equal to 1 over 3 plus 3, which is 1 over 6. And that is our answer. Now, what if we are given a different, this is the number 4, a different form of limit? Now, we are given the limit of 8n plus n squared divided by 4n minus n squared all raised to the power of 4 as x approaches infinity. Now, I can break this down to the limit as x approaches infinity of n divided by n plus n squared divided by n. See, I am dividing through by n. 4n divided by n minus n squared divided by n all raised to the power of 4. And this is equal to the limit as x approaches infinity of 8 plus n divided by, okay, 4n, or rather 4 minus n. I think I made a mistake here. This is supposed to be n here because we are dividing through by n. So all to the power of 4. Now, if I say that infinity is equal to 0, so I will have 8 plus 0 over 4 minus 0 all raised to the power 4, which is equal to 8 divided by 4 raised to the power 4, which is equal to 8 divided by 4 gives me 2 raised to power of 4, and that is equal to 16. Now, in my next video, I will explain why I say that infinity is equal to 0